Hello everyone, I am Tarun Prajit from CSEA, graduating in Stephen Regression College of Engineering, and I am here to discuss about the topic correlation and regression with Karl Pearsons coefficient of correlation. Understanding correlation and regression can be daunting, but it's essential to data analysis. In this presentation, we will dive into the Karl Pearsons coefficient of correlation and its application and limitations. In this slide, we will discuss what are correlation and regression. First, when we come to regression are those analyze the effect of one or more independent variables on a dependent variable. It helps in predicting the outcome for a new observation. When we come to correlation, it describes the relationship between two variables. It measures the direction and strength of linear relationship between them. And Karl Pearson's coefficient. It is the statistical measure of linear correlation range from +1 that is perfect positive correlation to -1 that is perfect negative correlation with 0 indicating no correlation. And the calculating Pearson coefficient of correlation formula is being given here. You can see it. In this slide, we will be interpreting the Pearson's coefficient of correlation. When we come to positive correlation, when both variables change in the same direction, the coefficient is positive, that is +1. The graph is given here. And when we come to the negative correlation, when both variables change in the opposite direction, the coefficient is negative, that is -1. You can see the graph for negative correlation here. When we come to no correlation, when no relationship exists between two variables, the coefficient is 0. That is no correlation. And when we come to strength of correlation, the closer the coefficient to -1 or 1, the stronger the relationship between the variables. When the coefficient is closer to 0, the relationship is weaker. In this slide, we will discuss the applications of correlation and regression in different fields. When we come to finance, correlation and regression are used in portfolio management and asset pricing. When we come to healthcare, correlation and regression are used to identify the relationship between patient characteristics and outcomes. When we come to marketing, correlation and regression are used to identify consumer behavior and preferences. When we come to social science, correlation and regression are used to analyze survey data, opinion polls, and experiments. In this slide, we'll discuss about the limitations and assumptions of correlation and regression. Linearity. Correlation and regression assume that the relationship between variables is linear. Outliers. The presence of outliers can affect the accuracy of correlation and regression. Causation. Correlation does not imply causation. A strong correlation between two variables does not necessarily mean that one causes the other. Sample size. A large sample size improves the accuracy of correlation and regression. In this slide, we'll discuss about the regression analysis and its relation to correlation analysis. When we come to regression, regression is simply the process of finding the equation of the straight line or a curve that models the relationship between two variables. Whereas when we come to correlation, quantifies how strong the association is between two variables. When we use regression analysis, we aim to find the coefficient for the equation that best explains the relationship between the variables. Correlation and regression analysis can be used together to form a clearer picture of the relationship between two variables. In this slide, we will see some real-life examples of correlation analysis. Some of the real-life examples are business, neuroscience, and sports. Business correlation analysis can be used to identify the relationship between different sales channels and customer demographics to help business optimize their marketing strategies. When we come to neuroscience, correlation analysis can be used to identify the relationship between brain activity and cognitive or emotional states. When we come to sports, correlation analysis can be used to identify the relationship between a player's physical characteristics and their performance on the field. Conclusion. Karl Pearson's coefficient measures the strength and direction of the linear relationship between two variables. Applications used in fields such as finance, healthcare, marketing, and social science. Limitations. Assumption of linearity, outliers, causation, and sample size can affect the accuracy of correlation and regression. Correlation and regression analysis are essential tools in modern day analysis. With Karl Pearson's coefficient of correlation, we can measure and interrupt the relationship between two variables and make informed decision based on our findings. Thank you. Thank you for being throughout the presentation, and I hope you have understood the concept. And thank you once again.